So let's get started. We are super excited to have a great presentation for you, for having some exciting guests here on the panel. So first, I'd like to welcome Shehzad Nabi. He's the Managing Director and CTO of Waterfall Asset Management. And prior to Waterfall, he was a Managing Director in Asset Management Division at Goldman Sachs, where he managed fixed income technology, fundamental research technology, and the trading technology teams. And he started in, I think, even though now he's in New York, he started in London with Goldman Sachs, and he got a BSc in computer science from King's College, University of London, back in 2002. And the interesting thing is he's my batchmate. Same year he graduated. And Shehzad also at Goldman has been a sponsor of Women in Technology, the career pillar in asset management technology. So Shehzad, we are really delighted to have you here. Thank you so much for joining us.
Delighted to be here as well.
And our first speaker is Ameya Malonkar. He's a resident solution architect at Databricks, helping the customers overcome their data challenges. He's been an avid user of Spark and Databricks for about 7 years now. He's a subject matter expert in Databricks on data mesh. And prior to Databricks, Ameya led a team at Flip, where they focused on building and maintaining their single source of truth data Lakehouse at Flip. So he's been in the space, done that for a while, and now helping the customers. And finally, we have our very own Maciek, who's a co-founder of Prophecy. And before that, he's worked on many data engineering and machine learning products and has been an avid user of Spark for many, many years, almost since Spark started. And he currently leads product at Prophecy. Right, so I think Ameya will go first, and then I think Maciek will talk about add to that, and then finally we all are eagerly awaiting what Shehzad has to say from all the exciting stuff they're doing at Waterfall Asset Management. So with that, Ameya, please take it away from here.
Thank you, Raj. Give me a second while I share my screen. Okay, I hope everyone can see my screen here. Okay, perfect. So, hello everyone. As Raj said, my name is Ameya, and I come from Databricks, and I'm really excited today to talk about how we can implement data mesh on a lakehouse. So, before we dive into data mesh, it is important to understand the motivation behind it. So, if you look at most of the organizations, you typically have this centralized data model, where all the data is sent to a centralized analytics team. And this enables consistency. However, as you can see, one of the major problems with this model is it creates bottlenecks quickly. Secondly, the team that is doing the analytics actually does not have the domain knowledge, which impacts the quality of the analytics that is generated out of it. And then you move into other side of the spectrum, which is a distributed data model. This is where typically you see in a bigger companies where you have individual teams building their own data stacks and managing their own data. But because of the lack of sharing and reuse, you end up creating a lot of silos, and then you run into issues where you have same metrics being reported in different manner in different teams. Data mesh is all about that striking that balance between centralized and distributed. It is about enabling teams to own their data, but at the same time, ensure that there is enough data reuse and data sharing managed by governance policies. Now, data mesh at its foundation is based on the principle of decentralization and distribution of responsibility. But this is made enabled by the 4 pillars of data mesh. Number 1 is domain ownership. This is where we talk about creating data domain teams that are responsible for creating and managing their own data. They are decentralized, they are autonomous, and the best benefit of this is that the domain teams are the one with the domain knowledge, and they are the ones building the data products. This brings me to the second pillar, data as a product. This is where we apply the classic product management principles to your data now. Now you think about how is your data being produced, and how many users of data do we have, and how the users are using it, or even think about concepts like, is your data actually trustworthy? Are they trusting your data? And this is where you bring in metrics like NPS scores and measure it on an ongoing basis to make sure your data is used properly and is of high quality. Next pillar is a self-serve platform. Now, with this all distributed and autonomous teams, if each of these teams start building up their own infrastructure, it is not going to scale quickly. So this is where you need a self-serve platform which enables these data domain teams to actually bring up data products quickly and build those data products faster without worrying about how to maintain and manage an infrastructure. And lastly, all this comes together because of federated governance. This is what makes decentralization work in cohesion. Now, this is where all the data product owners from individual data teams come together, agree upon a set of policies and standards to make sure that a healthy and an interoperable data mesh ecosystem works together. Now we talked about data mesh. Let's look into the motivation behind a data lakehouse. Now, this is a data and AI maturity curve, which shows that the competitive advantage of an organization or a team within an organization, how it increases as it matures on a data and AI journey. Typically, an organization starts from the left side of the graph where you just start collecting data and doing basic analytics on it. So you start looking at how many users I had last year versus this year, if my product A did better than product B. So this is all hindsight reporting we do. But as you mature more, you start looking into the future and start doing predictive analytics. So this is where you start predicting what will happen in the future, what are the possible options we have to respond to those events, and even get to the pinnacle where we start letting machines or the AI systems make those automated decisions. A classic example is a self-driving car, which is continuously evolving continuously making decisions based on its environment about what is the next best decision that to make to keep the driver safe in the car. Now, if you look at the different companies and different teams within the companies, you will notice that they are at different positions in this graph. Very few companies have actually made it to the top right corner, and most are hovering somewhere in the middle or to the left. And which begs the question of what is actually impending this? What is actually causing these companies to not get this fast growth onto the right side? Now, if you dive deeper, you will see that you have companies or teams have typically two types of tech stacks. You have a data warehousing tech stack to support your BI workloads, and this is where you require structured data. And on the right side of the when you go into machine learning and AI, this is where you build a data lake tech stack, and because your machine learning algorithms need access to raw and unstructured data. And now you have data engineering pipelines built to move data between data lake and your data warehouse on back and forth, and also maintain the consistency between them. So a lot of engineering time and effort is spent in keeping the copies of data, as well as ensuring the consistency and maintaining these two tech stacks. Now, this is where a lakehouse comes in, which is a single unified platform for all your data engineering use cases. You can support data engineering, data warehouse, data science, machine learning, all based on the same tech stack. So you don't have to maintain multiple copies of the same data. It supports all types of data, such as structured, unstructured, and semi-structured data. And last but not the least, it is it is not locked into an open, into a proprietary format. The data is kept in an open format, and as well as built on top of open source technologies, so that you can integrate with other open source libraries out there and fast pace your bootstrap development of data and AI. Now, Databricks Lakehouse platform is the pioneer of the Lakehouse architecture. It is based on three main principles. One, it is simple because it unifies all your data warehousing and AI requirements into a single platform. Second, it is open because it's built on top of open source technologies like Apache Spark and Delta Lake. Lastly, it is multi-cloud, so you have a same platform which can be deployed across multiple clouds like Azure, AWS, and GCP. Now let's look into how actually all of this comes together. Now, Databricks Lakehouse and a data mesh are not competing technologies. They are actually complementing each other. A Lakehouse is a format that can enable you on your data mesh journey. In a Databricks Lakehouse, you have this concept of workspaces, which is the smallest deployable unit. This is where you collaborate on your code and your data assets. Now you have two options here. You can organize your data domain teams around these workspaces. So you can give a workspace to each domain team for complete autonomy, or you can also share a workspace between multiple domain teams, but yet still get that isolation and autonomy by use of ACLs. Each of these data domain teams are in themselves maintaining their own full lakehouses. At the center of all these multiple workspaces and lakehouses is your Unity catalog, providing the necessary governance layer here. Now let's look back and see how data mesh and Databricks Lakehouse actually works on those data mesh principles. So you have data domain ownership. Now with the implementation of those workspaces, you get the autonomy to collaborate within your team, at the same time be isolated from other teams and operate completely independently. Then data as a data product. So you can deploy your data in Delta Lake, which provides you ACID guarantees and auditability. At the same time, you can also go further and share your data outside the organization leveraging open source Delta sharing. Then self-service platform. So you can, Databricks Workspace comes with built-in workflows engine, which you can use for building your pipelines, and also a central platform team can deploy these workspaces and manage these workspaces using our Terraform provider, providing the necessary infrastructure as a code management. Lastly, you have Unity Catalog, which provides that governance layer and provides the necessary discoverability, accessibility, and lineage for your entire data lakehouses. With that, I will pass it on to Maciek to talk about self-serve with low-code.
Awesome. Thanks, Ameya. Okay. Cool. So this was a really good introduction to the data lakehouse and how data mesh works on top of it. Hey, everyone, really excited to be here with this great audience and gonna show you how an organization can achieve self-serve with Prophecy low-code platform on top of Databricks Lakehouse. Data mesh is focused on enabling the domain data teams to build their own data products from operational sources and publish them across the organization. This is where self-serve comes in. Thanks to the domain data teams, they are meeting their technical level of their expertise. They use the self-serve data platform to build and publish data products with the support of the data platform team that provides them with the central governance and standards. So domain data teams, self-serve platform, data products, and the central standards with governance. Those are the four core pillars of the data mesh architecture. People these days define the concept of the data mesh very abstractly. Often they speak in terms of microservices, but here we're going to take a very practical approach that can provide you value quickly. Thanks to the data lakehouse, Databricks brought the medallion architecture to the mainstream. It usually consists of the bronze, silver, and gold dataset layers. The bronze layer has an exact copy of your data as it arrives from the operational systems. The silver layer starts with cleaning and augmenting the data. And then finally, the gold layer consists of the cleansed data that is combined together for the business analytics. The platform setup, data ingestion, and the bronze layer creation is usually done by the platform teams. And the data cleanup for silver and gold layers is usually done by the domain data teams. They are the ones who understand the data model and the business objectives. Previously, this wasn't really possible as it required high data engineering skill. But today, self-serve platforms enable anyone to build their data pipelines and publish their data products to the whole organization. Okay, so we talked about self-serve platforms, and that's because they're really important. They enable the domain and platform data teams to rapidly build and publish and consume the data products. But let's take a look at how self-serve platform what should it consist of. So first of all, a self-serve platform has to provide you a low-code development environment. Gone are the days where the top data engineers from the best universities are the only ones who are able to write the high-quality code. The truly modern low-code tools not only provide you the ease of visual development, but also can turn all the hard work that you put into native performant code. This enables all your businesses and business stakeholders to access a larger talent pool. Even the data practitioners that are already part of your business teams can now start contributing. This also enables the every data practitioner to be 10 times more productive, since they can see exactly the data model and the data preview in real time. Secondly, a self-serve platform has to be built out of reusable building blocks. They form the standard data pieces of the execution logic, and they can be shared across many teams. The platform should come with strong foundation of pre-built out-of-the-box standards, but it also has to be extensible. It has to allow for creation and reuse of user-defined blocks for business-specific use cases. Thirdly, since domain data teams are going to be producing and sharing data products across different teams, they have to have an easy mechanism to do that. This is where they can start searching for the existing data sets. They should be able to understand the quality metrics of those data sets and understand how they are currently being used and created. Next, as the business consumption of the underlying data platform increases, on top of Spark, data warehouses, and Databricks, the performance is its most impactful consequence. So the aspects of cost and performance have to be tracked and measured accordingly. Finally, the self-serve platform should not make any sacrifices from the best software engineering practices. Everyone should benefit from the robustness of the modern code-based deployment processes with Git at its center. Okay, wow, that was a lot to ask out of a single platform, but I am really excited to be here to show you Prophecy, which is the only self-serve tool that enables everyone to be as productive as the best of the best data engineers. Firstly, Prophecy provides a true visual-to-code development environment. As you're dragging and dropping the basic building blocks, which we call gems, that represent your sources, targets, and transformations, a high-performance code is generated for you in real time. As you're dragging them, you can even learn how Spark works behind the scenes and become really productive. Also, all the gems that we provide you are completely extensible. There is a basic standard palette that consists of even the more complex operations like slowly changing dimensions and complex merges, but you can also bring your own gems and extend the platform freely. As your teams develop new data products, all of them become immediately searchable. You can exactly see all of them and the end-to-end lineage directly created from them that's computed live based on your code. Additionally, you have the full control over which teams have access to which data products. As you're building out your pipelines, you also can automatically schedule them directly from Prophecy and build out Databricks jobs. As they are scheduled and running in production, you can actually see the data behind the scenes, the profiles of the data, the performance metrics, and even the cost behind every single job. And all of this, all the way from development to scheduling, is directly done on your Git infrastructure, enabling the best software engineering practices and CI/CD. Data Platform Foundation built upon Databricks Data Lakehouse and Prophecy as the self-serve tool, truly unlocks the data mesh for your organization. Now, the data platform teams, formed of those skilled engineers, can focus their time and effort on where it's best used. They can ensure the stability of the platform and create standards and recommendations. Those are then shared and enforced throughout the organization using the self-serve product. Domain data teams can focus on building the data products independently while managing their own set of standards and governance rules. Additionally, the data teams can collaborate between each other with ease, as all of their work is quickly searchable and identifiable. Okay, so this sounds all great in theory. Let's think a little bit more about the practice. So we're gonna straight jump now into demo, and I'm gonna show you three key components of Prophecy directly working on top of Databricks. We're gonna look at the low-code platform that enables everyone to be productive on Databricks. Then we're gonna look a little bit more from the domain data team's perspective, how to build and publish your data sets and look at the overall end-to-end lineage. And we're also gonna look from the data platform team perspective on how to create standards that can be reused across your organizations. Okay, so let's straight jump into Databricks. Okay, so this is my Databricks workspace. Databricks is the only dependency here for you to start directly using Prophecy. This is the only prerequisite. And on Databricks already, I have set up here a bunch of tables and databases that I'm gonna start leveraging. Those are all structured in this medallion architecture. I have my compute running here that I'm gonna start leveraging. And this is where the partner connect is. Now, Prophecy is one of the Databricks partners. So with just one click, I can now sign in and open the Prophecy ID. As soon as I sign in, this is the first screen that I'll be able to get, my Prophecy ID. And from here on, now we can get started. So what I would like to show you is how a member of a sales analytics team can easily collaborate with other teams and develop an end-to-end reporting pipeline directly on Spark and Databricks. It's not going to be just any report. As always with Prophecy, we're going to build a completely reliable production-ready data pipeline with all the code stored on Git, completely scheduled. We are going to run CI/CD under it and build even a small observability layer under the hood. Okay, so there is a lot to be done. And as you can see here, I have a bunch of teams already onboarded on top of Prophecy, and those teams own different projects. I have my marketing, sales, and data platform team. My data platform team has built out some SAS ingestion, the bronze layer, and my marketing and sales teams have started leveraging those and building out the actual reports. If I open up my sales reporting team, I'll be able to see that I already have some cleanup pipelines built out and some basic reporting done as well. I can look at all the data sets available to me, and I can exactly see how is the data set being created. With just one click, I jump directly into the lineage view where I can see how has been this data set created. Okay, so this is one of the data sets that I would like to use for my reporting pipeline. I can quickly explore all the columns that are available to me. One of the columns I might want to use is the account balance. We can very quickly see how the account balance is created by the other upstream teams within my organization. Okay, this is looking great. I have the full understanding of the data behind the scenes. Let's get to the actual work. So I'm going to build out a new pipeline. It is going to be my monthly reporting pipeline. And I'm going to place it in my sales reporting project. That directly brings me to the low-code canvas of Prophecy. This is where I have few important things to notice. One is that we're automatically connected to the Databricks cluster. But if I don't have one existing, I can very quickly also spin it up. On the left top, I have all of the gems available to me. This is where my sources, targets, transformations, and any custom gems built out by my other teams exist. At the bottom, something that data engineers that are a little bit more skilled usually really like, I have all of my Git information, and I can actually see that I'm right now on a development branch. But let's go ahead and start building our pipeline. In my project browser, I can see all of the data sets that are available to me. Some of those data sets are created by my data platform team. They're straight the bronze layer out of the ingestion, and some others are created by the sales reporting team. I'm gonna start from my silver layer. So let's drag and drop my customers data set. That's super easy. And let's define a completely new data set right here for my orders. With Prophecy, building out new data sources is really easy. You have all of the different connectors available right here. One click away, you can just pick one of them. We support all the Spark connectors out of the box, plus provide a bunch of different enterprise-ready connectors. I can pick very quickly my database that I would like to use. This is going to be my Lakehouse database and my orders silver table. With just one click, I can load up the schema directly from my Databricks catalog. And it's going to be right here. And then I can also modify how I want to read this data set. This is a Delta-based table, so I can focus on specific version revisions, for instance. There we go. So we have the schema loaded up. Let's quickly look at the preview as well. And that preview is automatically for us loaded up from the Databricks cluster. There we go. All of the columns. This is looking fine. Perfect. Okay, so now we have both of our sources loaded up. Let's start joining them together and building our actual report. I can very quickly drag and drop my join component, connect it together. And this is one of our first transformations. As soon as I open up the transformation component, I can see all of the columns available to me on the left-hand side. And now I can just very easily start building out my actual business logic transformations. When writing out the column, I get the expression builder. I can see all the columns available to me. And if I make any mistake, Prophecy in real time tells me about it. Perfect. Now we have our join ready. As we are building our transformations, of course, we would like to start running our pipeline as well. We would, of course, like to make sure that we are doing it right. And so I can very quickly just click on the play button and start seeing the data flowing in real time here for me. As this data is loading up, we're still working here with quite a big data set. So let's just go ahead and keep building our pipeline. I will drag and drop my aggregate component, connect that together. And this is where I'm going to start calculating some of the monthly report spends. So in my group by, of course, I would like to group by my customer key and the month itself. We can use a function. Now, as you're writing the functions in Prophecy, we give you an expression builder as well, right? So that really the only thing you need to know is basic functions, almost like from this Excel formula, maybe a little bit of SQL expressions. That's the only thing you need to be truly productive. At the same time, we would like to, of course, now that we have the group by, let's aggregate and sum up our amounts. So we have our total prices, which I can sum up and create my amounts column. Perfect. So now that we have our aggregate, we can already see that the data has started flowing through our pipeline as well. And we're processing all of those hundreds of thousands of records. This is how our orders look like, where I have a row, every single order represented as one row, and my customers. After joining the data together, now I have all the orders associated with their corresponding customer. If I want to, I can deep dive into this data as well and see specifically the profiles available for every single column. Cool, so we have our join, we have now our aggregate set up. but I really wish that this pipeline was running a tiny bit faster, right? This is running really well on Photon. We're still processing a lot of data here, but we would like to run it a little bit faster. The typical practice would be to set up some smaller development data samples, but who really has time to build those? So thankfully, Prophecy provides you a bunch of different usability tricks to make this more productive. So I can actually limit the amount of data that I'm working with at any particular time, just to enable you to develop the pipelines a little bit faster. I'm just going to limit it to 1,000 records, and let's drag and drop our final target where we're going to write our report. Let's now run it and see how that works. And wow, perfect. Okay, well, this is now super smooth. Awesome. This is the snappy experience that we are looking for. I can see my aggregated data now for every single month. It's just that this data doesn't look beautiful, right? This is not the kind of report that I would like to give to any of my executives. So let's actually see what we can do. Well, turns out that one of our colleagues have already developed this enrich customers subgraph. This is a piece of functionality that someone else has built, but now I can just drag and drop that directly into my pipeline and start leveraging it. So let's see what's going to happen. Can just connect it right into my aggregate before my final write. And let's run it to see what kind of data are we going to get. Of course, every single component that is built out by your team, you can still inspect, look exactly at how it's functioning, or even configure it further. And perfect. So now we can see the data, and wow, this is looking so much better. So we have still our customer keys, that's fine, but now we can exactly see what are the regions that they are coming from, which nation they are associated with. The amounts are pretty formatted, and our months are finally readable. Awesome. So the last step now is just to write this data out. So this is where we are going to create a new data set. This is going to be my gold report that I'm going to write just as another table for now. I can, of course, see the schema available here for me. And this is where I can also control how they like to write this data. Typically, you might just go with something like an override on append, where you're just adding more records to your existing table. But as mentioned, we do have those really nice integrations with Delta, where you can also merge your data back to existing data sets. Right? This is where specifying merges is as simple as just choosing that option, or even leveraging more complex types of merges, like slowly changing dimensions. On the other side, of course, doesn't matter which option you pick, you would just get high quality code. So with that, let's create this target. And perfect, we can just run it one last time. Awesome. So while this is running, let's also look at the code that is being generated for you from all this hard work that you're putting in. I can just, with one click, switch directly to the code editor. This is where I see my pipeline and all the standardized code files available for me. So I can see that every single gem that was on this canvas is now turned into this really neat function directly inside your PySpark. I can click on any one of them, explore how they are being written. And I can, of course, even explore my actual subgraph that I have dragged and dropped from someone else. If you're a programmer, you should start feeling right at home by looking at this interface. Okay, so let's go back to our design view and let's quickly schedule out our pipeline. We're gonna create a completely new schedule. This is a monthly report, so we'd like to run this monthly. Let's very quickly pick. It's gonna run on the 1st of every single month, and we can set up some basic alerts for us available. Awesome. Now we have the schedule built out. Our reporting pipeline is gonna run monthly. Let's now go ahead and deploy it to production. We can do that with just one click. There is this release button available right here. And that's gonna take us directly to the Git view. Git is really awesome, but sometimes might be a little bit difficult to use, even for the more skilled engineers. We're trying to make Git easy for everyone. So right here, you can see your development branch with all of the previous changes and your production branch with all the changes that are currently deployed. With just a simple step-by-step process, we can take all the changes that we've done and deploy them directly to your production environment. We can see the new pipelines that were built out, the new data sets that were created, and even the automatically generated commit message for us. Let's go ahead and commit all of those changes. Merge them directly to our branch. If we do want to follow PR review processes, of course, we can do that as well. And let's deploy our version to Databricks. As the deployment process starts, this is where the actual CI/CD is being executed. Continuous integration will automatically build our artifacts and run any tests on them. And continuous deployment is going to take all of those pipelines and packages and deploy them straight onto your production environment directly on top of the Databricks workspace. There we go. That process just took under a minute. I have my jobs deployed, and I can actually see them directly on Databricks as well. So once I open my workflows, I can see my new monthly job being created for me as a standard Databricks workflow. Awesome. So just like this, we have built out our complete pipeline. We have scheduled it, and now it's running in production. Very quickly, we can also make sure that the pipeline is running by doing a little bit of observability, looking at the data behind the scenes for each of the pipelines. I can open up my monthly reporting pipeline. This is where the cluster is loaded up. I can see all the historical runs, and I can see how many rows were read at each pipeline run, how many rows were written, and how did the pipeline look like at that particular point in time. There we go. All the profiles of the data available to me as a straight up visualization on top of my data pipeline. Just like this, in few minutes, we have built our reporting pipeline as a member of the sales team, leveraging a bunch of other components from other teams like data sets and subgraphs, and productionized our pipeline, made it run reliably on our Databricks production workspace. Cool. Shazad, off to you now.
Yeah, hi Shazad, I think you're muted, but one quick thing, guys, keep questions coming. As your questions are there, I'll keep answering them, and then at the end we'll show the results of the poll. We'll also take some questions and answer them live. So please keep your questions coming. Yeah, Shazad, very excited to listen to you. So please take it from
No,
here.
thanks for having me. So let me start quick. Obviously, you gave me a good introduction. Thanks for a very thorough, detailed background introduction, Raj. Waterfall is a structured credit asset manager firm. So I joined Waterfall just over a year ago. So we are in a very exciting phase of our digital transformation journey. So I'll before I get going into what Maciej and Amaya talked about applies to Waterfall and how we are planning to use it and our roadmap for the future, I want to throw some color in terms of what the past is, right? So keeping in mind one of we have primarily two objectives. One of our goal is to provide operational scale and efficiency in our firm for our investment professionals and across the board, and also use basically data to make investment decisions going forward. Data is becoming more and more important, and the type of investments we do are around structured credit, whole loans, residential, commercial real estate markets. So to give you some color, I have in my experience over the past so many years within financial world, usually it's been a very traditional software development model, right? You have business analysts, usually sometimes they're engineers, sometimes they're not, right? They go and speak to a person who really is the domain expert. The person says, I want something, and that translates into requirement. Engineers go and figure out how to get data, how to develop software, how to spin up infrastructure, whether it's traditional databases, storage solutions, and then deploy the application. And then the investment professional looks at the output of the investment application, looks at it, provides more feedback, and that whole process continues, right? So that in itself is a very slow process, right? So in order for the investment professional to make decisions, they need to first look at the data. The data can only be delivered in a manner which the engineers can target, and as a result, you basically have these bespoke applications which are built targeted for domain experts who use those software, and that highlighted few issues across many years, right? So some of them is time to market. It takes a long time from idea generation to have a product. Information gets lost in translation. People are not the domain experts, so they may develop certain things which are not necessarily how they are applied to real world markets. And then data, which I think is the most important, data is as good as the application, right? So if the application is designed with some foresight, obviously it will add significant value. And what I mean by applications is these could be dashboards, these could be visualizations tools, these could be just actual interactive tools which allow manipulation of data as well as some workflows. And over time, it relies on engineers to really become the domain experts. So as a result, this process obviously has been in the industry and to some extent still being utilized. Now, that doesn't mean it's necessarily a bad thing. It created certain trends, right? People found creative ways to solve problems. Some good products were developed, which were then obviously adopted across the industry as well. And then it created the breed of effectively what we call quants nowadays, or data scientists in the modern terminology, which is effectively people who are domain experts but are actually very tech savvy, so they build smart solutions. This approach tends to work for large institutions. And so with that backdrop, which is not a scalable solution for majority of the organizations. Even with large institutions, as the modern infrastructure is becoming as code, it's very hard for them to pivot from their traditional way of doing things. So fast forward to where we are today. For next slide, Majid. So in the present environment, what happens is we have traditional data warehouses, right? Whether these are Lakehouse solutions or equivalent from a technology point of view, or SQL, Oracle, and other databases, they basically provide the storage mechanism where your data is stored. It is being used by investment professionals through improved BI solutions like Power BI, Click, Tableau, etc. Right? So those tools are pretty good in terms of investigating data, coming up, developing insights, and those tools are sometimes used by engineers as well, right? But primarily the people who are a little bit more data savvy. And then you also have engineers, programmers who are developing the actual scalable platforms and solutions. So imagine if someone is trying to look at real-time market data, or someone is trying to look at large data which cannot be ingested in a traditional BI tool, so that creates birth of new applications which engineers get involved and develop on the back of the same warehouse. So this model is pretty good and sophisticated, but it creates entropy in the environment, right? So as an example, investment professionals might come up with a function which allows them to compute, let's say, market value of an instrument. Now that function is needed in other parts of the infrastructure. So suddenly you have different data models, right? So this diagram is trying to depict that. The idea is that you start creating those functions, you have different data models, and then suddenly there is reconciliation in place. Two numbers don't match up. So that creates entropy in the environment. So majority of the time, what people end up doing is they copy data from one place to another. Then you create processes to reconcile the data, error check whether it has made it from one place to another. You transform it, and most of the transformations are time consuming, because you're effectively trying to transform data into a format which is usable for your end application or use case. So this is the environment generally where we are currently. While it is very proficient, it gets people more closer to the data, but you create complexity in the environment where there is diversity in the business logic. And given the environment we operate in, it's important for us to not get the numbers incorrect, right? There is a fiduciary responsibility for organizations like us. So with that mindset, we obviously started our journey into the future, which is effectively the data mesh, right? So data mesh is, so if you switch to the last slide. Yeah, so data mesh effectively is this, to me, gives a picture of where we want to be. So obviously we are also in our journey, we adopted Databricks as our central storage data warehouse solution. But it gives us certain I guess benefits in terms of the Spark deployment. So with Prophecy, now there are traditional tools out there which allow drag and drop low code solutions in terms of data transformation, but they are very they're tied with the old deployments. Like you have to bring data in memory, you have to run transformations, and you can only do what you can do within the confines of your storage solution, right? So we were looking for a non-traditional solution to this. So with Prophecy, Databricks, we are able to basically complement our strategy. We want to be in a position where our investment professionals, technology engineers are coding on the same ecosystem. They're sharing the libraries. So if someone has written a function which provides a metric that is valuable for our business, we want to be able to reuse and share it. So as a strategy, we are not copying data in other places. Everything is stored in Databricks. For us, we use Prophecy as a low-code environment. It allows our, effectively, if you think from a data science perspective, idea generation to take place at a faster speed. You can take a file, you can take data very quickly, onboard it, try it, experiment it, and actually deploy it very quickly without having to speak to a team of engineers to transform data, bring it in-house, load it, clean it up, and then make it available for someone to use. So this, I think, for us is giving the benefit of condensing our entire life cycle of onboarding data and making it usable. As with all things, this is a journey. So I would say we're in the middle of it. So there are obviously a few gaps that we want to address. Some of them are not native in the platform, and that's where we are working closely with these products to develop those, like schema management, right? So to me, schema management should be centrally controlled. It's not something that should be disparate in different tools. Same with data quality, right? Data quality generally tends not to be built in. So we are working towards building our own complementary solutions on top of it to provide quality controls on the data. And these are not just simple error checks on the schema level, which come through native tools, but it's more beyond that. Like if, for instance, if a metric has changed beyond a 20% threshold month over month, why is that, right? So we want to be able to catch exceptions like that. And then on top of that, build intelligence tools and analytics, and whether that's in the form of BI tools without copying the data to the BI tools and create entropy, or much smarter predictive tools. So that's our journey. I'm hoping there will be some questions, and I'm happy to answer those questions. But generally, the idea is that use these modern tools and data mesh ecosystem that is out there, so that we create a unified platform for our investment teams as well as our engineers, so they are collaborating and working on the same ecosystem.
Thank you so much, Shehzad. Thank you so much, Maciek and Ameya. We've had questions flowing in. I've been trying frantically to answer them, some of them that I can as soon as they come. There's other questions for you. So first, Shehzad, there's one question for you. Is like, given new technologies in the cloud, how do you build the tech stack differently than Goldman Sachs?
Very good question. So it has empowered us in so many ways. We are able to utilize the modern technology and innovation faster. And there is a backdrop to this, right? So 10 years ago, cloud did not exist in its current form, right? So there was nothing out there. So, but infrastructure has become more like a commodity, right? It's like television. You go and buy it and plug it in, and it works. And same with whether it's with Azure or AWS or other services, it's the same thing. So it empowers us not to spend time building the platform, right? So we in a smaller organization, we are very targeted in adding value. So there is no add value for us investing and coming up with new ways of deploying software, as an example, right? So we want to use a platform that is available and outside, out of the box, and works for us. So that's where I think there is a mindset difference, and it has allowed us to onboard tooling like Prophecy. To give you an example, Prophecy would have been a struggle to onboard in a bigger organization because of the large nature of the firm that exists, right? So, and in someone would come up with the same idea and build it in house anyway. So I think that's where I think it allows us to tap into tools which are coming out and stay nimble, and that's why the goal is to stay open source and easy to change and adapt to these modern tech stacks that appear over time.
Cool. Thank you so much, Shad. Amir, a couple of questions have come for you. And I'll ask both of them, and you can answer them in any order. So one is, how is Data Lakehouse different from Data Mart? That's one. And the second, let's start with that, and then I can go to the next one. Yeah.
Sure. So Data Mart, Data Lakehouse, yes, I understand the confusion that they do sound similar or have been are built on the same principles, but the overall idea of Data Lakehouse and in the data mesh format is you're giving the ownership to the data domain teams. So now you don't have a centralized data team doing everything for all the business units. It is offloaded onto the data domain teams who are actually managing the data that they produce. And on top of that, the data lakehouse is kind of a versatile architecture which can map to data marts, data mesh. So it is just like an enabler for all these different architectures sitting out there.
Cool. Thank you. And then I have Jonathan asking is like, can Shehzad share the high-level architecture of their data mesh implementation? So I don't know if it's easy to just explain it. Yeah.
Again, I can explain the idea in reference to the last slide that I went through, right? So if you think about it, Databricks is our Spark compute, right? And then we are also using it for scheduling the pipelines, as well as storage of our data. Now, on top of that, there is logic in terms of how we onboard data, and that's where Prophecy comes in. So the idea is that we can onboard data fairly quickly. You don't need to have engineers who have programming skills to onboard data, and transformation, right? So imagine if a domain expert knows how to transform data, apply certain validations and enrichments, that can be done using Prophecy. So that architecture allows us to effectively onboard data, make it available. Then there is a final layer, which is, I would say, is more proprietary for us, is where we control how we come up with derived data sets. And those derived data sets is where we as engineers and maybe investment professionals add value. We write them in the same notebooks as what we call citizen programming. This allows us to control what goes in our environment. Everyone can contribute. Very few people have the keys to the kingdom, so to speak, but people can actually use the platform. They can write functions, share, commit, create common libraries. So that hopefully will allow us to build an ecosystem around which we can develop our business logic in code. And it's open source in that sense that it's all Python, Scala as an example, right? So that's a high level high level, I would say our architecture. People access data directly. We are not, as an example, we are not developing any business logic in our BI tools, right? BI tools are designed purely for rendering. We are not doing any formula, anything. So if you want to charts, visualize, then we use BI tools like Power BI or Click or etc. Otherwise, everything is self-contained within the ecosystem of Python code within Databricks.
Cool. Cool. That sounds good. And Maciek, there's 2-3 questions that have come together. Can Prophecy, Harish is asking, can Prophecy support incremental pipelines? Usman is asking, hey, if the table were changing every 5 minutes, can you do CDC? So I think this is I guess, Prophecy, Databricks, both questions. Maybe Maciek, you can take this one.
Yeah, absolutely. So Prophecy sits directly on top of Databricks and Spark, right? So everything that Spark can do, you can do for Prophecy, including incremental data writes, right? So as an example, if you have a Delta-based table, Delta supports merge statements. Now for Prophecy, it's very easy to define those merge statements directly on top of your table. Right, we support things like slowly changing dimensions so that writing continuously even to tables becomes very easy. And from the scheduling perspective, right, you can schedule your jobs at whatever frequency you'd like, right? And then as those jobs run, they'll just incrementally keep writing the data to your target data sources. Something that we have coming soon as well is streaming support. So then with streaming, you'll be able to continuously just write data to your targets without having to think that much about the scheduling aspect of it as well.
Yeah, that sounds good. Amir, there's one question about the ownership and authorization. So it's like, how do different teams manage ownership and authorization when they're building a data mesh on data lake, right? Does the central team does it? Does the business team do it? So there's I'm summarizing 2-3 questions that have come around this topic.
Yeah. So in a data mesh and in data lakehouse, you can actually do this through Unity Catalog. And as per Unity Catalog, you can defer the permission granting to those individual data domain teams, and they can define the permissions for their own data products. So they will be able to give access to those data products to some other teams, and then they can the other teams can start consuming the data products built by this said data domain team. And everything is governed through Unity Catalog, so you will have one Unity admin, but who can give away admin permissions to individual data domain teams for their own catalog or schema.
Mm-hmm. And then one question for Shehzad. It's like, the vision for Celso platform is great, and it looks like you are actively implementing it. Are there any pitfalls you want to call out for other technology teams and CTOs to look for in their journey?
Yeah, I think the governance angle is the most important, right? So people who are going to use the platform when you make it self-serve, their objectives are not necessarily aligned from an engineering point of view as, let's say, from a technology team, right? And that's the right thing to think about. So someone whose goal is to, let's say, research an idea and come up with, let's say, some decision making based on their investment thesis, they are not going to think about, okay, am I modeling the dictionary correctly? Am I going to write this code with the right unit tests, right, so to speak? Or so the governance, I think, and fundamentals have to be baked in day one, right? So it's very hard to pull back and then it's like refactoring the code, right? It's always hard to refactor the code, and that project never gets prioritized, right? So it's important to think that from day one. And then the way we are approaching this is we like code approval process and promotion to production is completely within the approval process, right? So we have a two-tier approval model, so people can write code and run in their sandbox, but they cannot run it in production until they go through a proper peer review and code commits.
Mm-hmm. Sounds good. Thank you. There's one question that I'll take, even though as a moderator, I shouldn't. So there's a question about how do you compare to DBT? And so DBT is like a build system on SQL. And so basically, so like when we like Prophecy visually is generating Python, it's generating Scala. When it's generating Scala comes with SBT, a build system. Similarly, SQL didn't have a build system, and DBT has added that, but we are one layer above that. I think we should probably get to the last one or two questions. So I think, Shahaz, one question has come, and there's two different variants of this. But basically, they're saying, what has been the business impact? Are you able to move faster? Like, how is data mesh helping you? Or so there's some question around, like, is self-serve tool helping you? Is data mesh helping you? Like, what is the business impact? So I think I'm merging 2-3 questions there.
Sure. I think the data mesh helps us in a way that I don't have to maintain, let's say, warehouse solution. I don't have to maintain an application backend storage solution. I don't have to maintain, let's say, a reporting layer storage solution, right? So the mesh gives us one storage space. Obviously, there will always be edge cases, like if I'm doing a business workflow object model, I may use something like DynamoDB or equivalent. But from a data perspective, it's all in one place. So it helps us in terms of maintenance, less engineering work. I don't have to have, let's say, Spark engineers maintaining our environment. It's self-maintained for us effectively. We are not true admins. It's managed through the cloud. The other part, from a business point of view, I don't need to have my, let's say, technology engineers focused on data onboarding, right? So, so smart programmers don't want to just be in the business of copying data and then mapping it to files and storing it, right? So this allows us to diversify who can do that work, and as a result, anyone who's capable in the environment can do it, right? So that's where we have added value, and obviously, as I said, we are in this journey. We are fairly recent. I imagine that over time, people in the investment teams will be onboarding data that matters to them. The governance process will make sure it's stored and modeled correctly. But that's where we are already seeing the benefits. I don't have to have, let's say, key people in my team just deploying data pipelines. They can focus on more complex and add value solutions.
Cool. Thank you so much, everybody. I think we're out of time. Stephen, can you share the results of the poll that we had in the beginning? Since we promised everybody will do that, I think people are starting to drop off. So it says, hey, are you on the business team or the data platform team? I think 11% are in business team, 79% in data platform team, 10% in other. Do you use Databricks? Looks like 70% do, and 17% are looking to move. What is the biggest challenge for your team? You could choose multiple questions here. So 56 are saying transforming data for analytics takes too long. Next is 40% hiring people with the right skill set. Doing too much manual work is the third one. 39% and 30% say that they want waiting for another team to build data pipeline. So that speaks to self-serve for sure. And then does your team use low code? It looks like some do, some are interested, some are, some about 10-11% are not interested. Some are using it and happy. A good 70% are either interested or and looking for something better. And what does data mesh mean to you? And 70% is saying empowering business teams. And then number 2, 69% says making data products searchable and accessible, and 57% say providing data governance and standards. So this has been very exciting. And we are totally out of time. Thank you so much, Shehzad. Thank you so much, Ameya. Thank you, Maciek, for joining us on the panel. And thank you, everybody, for joining us. We're super excited, and we'll share the video of the recording with you. All right, everybody. Have a great day.
Thank you.
Thank you.
Thank you so much.